Good morning, dear students. Good morning, all of you. How are you all? Fine. Okay, so this is a video of class 11, and in this video, we are going to discuss about the topic, and that one is preparation of preparation of alkanes from alkyl halides. Okay, so you can see that here I will write the preparation of alkyl halides by alkyl halide, preparation of alkanes from the alkyl halide. So alkyl halide means Rx. In place of X I can take chlorine, I can take bromine, I can take iodine. Okay now, so this chlorine, bromine, iodine, if I will take, then the structure would become like a RCl, RBr. Okay now, so this one would be the structure, and you can see here that this rcl rcl, as this one is having the most electronegativity ability, showing the ability of accepting the electron is more as compared to this alkyl group. So that chlorine will accept the electron of R also, and this one is a polar molecules, so chlorine will become slightly more electronegative as compared to this R positive. So what it will form, it will form Cl negative, and it will actually take its electron and move from that compound. So Cl negative will act as a living group. Okay now, so it will take its electron and it will move from there. Okay, so what it will form, you can see that alkyl halide except fluoride I have not written, on treatment with zinc and dilute hydrochloric acid gives alkane. So you can see that here if I will take RCl, F is not possible. Okay now, high electronegativity ability of fluoride will form a strong bond with R, and it is not easy to break down that type of bond. Okay now, so on reduction with zinc, so whenever zinc you are taking some of the metallic element, so that one will actually act as a reducing agent. Okay, and you have to take the dilute hydrochloric acid. Okay, so that zinc, and in the presence of dilute hydrochloric acid, it will actually remove this Cl, and Cl will form a stable compound with H plus, and resultant it will, this R will gain one of the hydrogen from the dilute hydrochloric acids, and then it will form one of the stable compound, and that one is of alkanes. Okay, so second, you can see this one is the Woods reaction. Woods reaction, here it is written. What is the Woods reaction? If you have to get the higher member of alkanes, so from in that the preparation of higher members of alkanes, you can take this alkyl halides on treatment with sodium metal in triether. Okay, so this is called a Woods reaction, and here you will get the preparation of a Woods reaction, and that alkyl halide preparation also in this reaction I am going to show you. Okay, so please wait. Okay, so we are talking about the preparation of alkanes, and the second methods are for the preparation of alkanes, and that one is from alkyl halides. Okay, so here we will talk, there are two ways by which we can prepare the alkanes from the alkyl halides, from alkyl halides. Okay, so you can see the very first way is the reaction between alkyl halide with alkyl halide with zinc and dilute hydrochloric acid. Okay, now one method, this one, hydrochloric acid. And second method is Wood's reaction. Okay, now Wood's reaction will also give you the alkane from the alkyl halides. So one by one we will see what are these reactions. Okay, now how can we write the reactions? So first of all, we will talk about the reaction between alkyl halide and the zinc. Okay, now so here I have written CS3Cl, and here it actually are one of the reducing type of reaction. So I have added hydrogen gas to this one, and here zinc and H plus I have taken. So what will happen after some times? H will break down, dissociation. After dissociation, one H will go and react with Cl. So what it will form? It will form HCl. It will form HCl. So here I am writing HCl. Okay, now, and then you can see this CH3 will combine with this H, and what it will form? CH4. So this one is alkane, and which has formed from the alkyl halide. You can take the more complex type, more higher member of the alkanes, alkyl halide also. So here I have taken the second one, C2H5Cl plus H2 in the presence of Zn and dilute hydrochloric acid, means H plus I have taken only. So it will H2 again break down, and it will form C2H6 plus HCl. Okay, now so this is your ethane. In the very first one you have got methane, and in the second one you have got ethane. So these two examples which we have prepared from the alkyl halide, and we have actually prepared the methane and ethane from this alkyl halide by one of the reducing type of reaction in the presence of zinc and dilute hydrochloric acid. Now the second one is Wood's reaction, because we are doing from the alkyl halide, and both of the reactions we must have to do, because it is the parts preparation of the alkane. Okay, now so here we will talk about the that reaction from Wood's reaction, from Wood's reaction. Okay, now how? So alkyl halide, when reacting with sodium in the presence of dry ether, alkyl halide CH3Br, but there you should think you have to take even number of carbon, because if I will react it with two sodium element, then Na will combine with Br, because you know Na is having positive charge, and after this Br is more electronegative now, so it will take its electron also, and it will act as a leaving group, so it will remove from that alkyl halide, so it will form 2 NaBr. So I have to take, how the balancing is essential now, so I have to take 2 CH3Br. Okay, now 2 CH3Br, or if you don't want to write like this one, you can also write like this one, CH3Br. Okay, now in the presence of dry ether, what will happen? This Na will combine with Br, and what it will form, because you know Br, 2Br is there, so 2 NaBr it will form, and then after you will see that Br and Br has loose, so CH3 will combine with this CH3, and it has formed CH3.
So this one is the Woltz reaction and this one is the preparation of alkane. Here it is ethane. Okay now. So it is essential that you will understand that one alkyl halide when combined with sodium metal in the presence of dry ether, it will form after the combination of CH3 it will form ethane and 2 sodium bromide, 2 molecules of sodium bromide, 2 moles of sodium bromide will release out in that process. Okay dear students, so I hope you will do more example on that basis. Thank you.